Hi, welcome to Electrical Engineering. Today we are going to discuss some shortcuts in parallel circuit. ഇന്ന് പാരലൽ സർക്യൂട്ടിലെ കുറച്ച് ഷോർട്ട് കട്ടുകളാണ് ഞാൻ ഇവിടെ പറയാൻ പോകുന്നത്. അത് ഈ സർക്യൂട്ട് സോൾവ് ചെയ്യാൻ വളരെ എളുപ്പമായിരിക്കും. പ്രത്യേകിച്ചും കോമ്പറ്റേറ്റീവ് എക്സാമിനേഷൻസിന് ഉപയോഗിക്കും. Okay, let us start. In a parallel circuit, effective resistance is denoted by Re or RT. Then the equation is 1 by Re equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the equation. From this equation, we can solve Re. You know that. Okay. Here, 3 resistors of 30 ohm are connected in parallel. What will be the effective resistance? If the value of the resistors are same, then take the value of one resistor and divide that value with number of resistors. That is, here 3 resistors are connected. Then 30 divided by 3 is 10 ohm. അതായത് ഈ സർക്യൂട്ടിന്റെ എഫക്റ്റീവ് റെസിസ്റ്റൻസ് 10 ohm ആയിരിക്കും. ഒന്നുകൂടെ, രണ്ട് റെസിസ്റ്റൻസ് ഈക്വൽ ആണെങ്കിൽ അതിന്റെ എഫക്റ്റീവ് റെസിസ്റ്റൻസ് അതിന്റെ ഒന്നിന്റെ പകുതിയായിരിക്കും. അതായത് രണ്ട് 30 ohm റെസിസ്റ്റൻസ് പാരലൽ ചെയ്താൽ എഫക്റ്റീവ് റെസിസ്റ്റൻസ് വിൽ ബി 15 ohm. അത് മനസ്സിലായി. Next case. Case 2. Here, 3 30 ohm resistors are connected in parallel. Can you give the effective resistance of this circuit just by looking this circuit? This is my question. Okay. The effective resistance is 0. Why? Here, there is an absolute short circuit from this point to this point. That is, 2 lines are connected using a wire. That means a short circuit. So, these resistors have no effect in the circuit. Current will always flow through AC power. So, when we measure these 2 points, we will get 0 resistance. So, effective resistance of this circuit is 0. Next, third case. If there are 2 resistors, that means R1 and R2 only, then we can use this formula directly. Re is equal to R1 into R2 divided by R1 plus R2. This formula is obtained from this. If you solve this equation, we will get this equation. Okay. Then we can check. Here 3 ohm and 6 ohm are connected in parallel. Using this equation, 3 into 6 divided by 3 plus 6, that gives 2 ohm. So effective resistance of this circuit will be 2 ohm. Case 4. A parallel circuit consisting of 2 resistors, R1 and R2. And we know the entering current. Also we know the values of R1 and R2. Then we can find the branch current very easily. Branch current IR1, that is current flowing through IR1, equal to entering current I into opposite branch resistor. Opposite branch is here R2 into R2 divided by sum of the resistors R1 plus R2. That is equal to 12 into 6 divided by 3 plus 6. Then 12 into 6 divided by 9, we get 8 ampere. 8 ampere. That means 8 ampere will flow through R1. Entering current is 12 ampere and 8 ampere separated from 12 ampere and flows through R1. Then remaining current is 4 ampere. And 4 ampere will flow through the second path. This is the method. Or 12 minus 8, that is equal to 4. Or R2 equal to entering current I into R1 divided by R1 plus R2. 12 into 3 divided by 9, that is equal to 4. Case 5. Here 4 resistors are connected in parallel. 1000 ohm, 1 ohm, 100 ohm and 5 ohm. Can you tell what will be the effective resistance, approximate effective resistance of this circuit? It is very easy. It is less than 1 ohm. In a parallel circuit, effective resistance is lower than the lowest resistance in that circuit. ഒരു പാരലൽ സർക്യൂട്ടിൽ എഫക്റ്റീവ് റെസിസ്റ്റൻസ് അതിൽ കണക്ട് ചെയ്തിരിക്കുന്ന ഏറ്റവും ചെറിയ റെസിസ്റ്റൻസിനേക്കാൾ കുറവായിരിക്കും. ഹിയർ ദ ലോവസ്റ്റ് വാല്യൂ ഓഫ് ദ റെസിസ്റ്റൻസ് ഈസ് 1 ohm. So effective resistance will be less than 1 ohm. This is another shortcut. Okay. If you like this, please share and support me. This is Srikumar signing off until meet again.